Hello, good day, welcome. Today we are going to learn how to control the position of this new kind of motor. This is a servo motor, and the special characteristic of this motor is that we have control of the shaft position. If you remember, the previous motors we have been using keep spinning forever, and we have no control on the shaft position. In this case, if you try to turn the motor to the full spin position, you will see it's impossible. There is a mechanical limit. That's because this motor is not designed to complete a full spin, because we don't need this to keep spinning forever. We just need to get a precise control on the position. Internally, you may be able to identify perhaps, let me see if it's possible. Yeah, maybe this way you can see that internally there is a direct current motor, just like the one we used previously in the motor reductor used in the previous video. So internally it has a direct current motor. Therefore, we need to provide power to this motor. We need the positive connection, that is the red one, the negative connection, that is the brown one, and we got an extra connection. This extra connection is the data signal. We use this connection to send a specific signal to specify the position we want in the motor shaft. So internally it has indeed the direct current motor, but also it has some electronical circuits used to control the proper position for this shaft. Now, this time we are going to control the position of this motor with this. This is a photoresistor, and as I have explained previously, there are a lot of resistors available in the market. Some of them have fixed values, like the ones we have been using previously. These kind of resistors are fixed value resistors, but there is also some variable resistors, like the potentiometer. We have been using this, if you remember, really fast. Internally it has this resistor element, and then this element, it's the wiper, and it is connected to the shaft of the potentiometer. So if you move the shaft of the potentiometer like this, if you spin the shaft, the wiper position changes, and then depending on the position, it's the resistance you got. So we got fixed values resistors, and we got variable values resistors. This time this is a photoresistor, and it is a variable value resistor. The value of the resistance of this element depends on the light over this surface. If you cover this surface, the resistance value is going to reduce. If you uncover, if all the light gets in this surface, the resistance increase. So depending on the light over this element, the position for the motor shaft is going to change. So let's get started. This is the circuit for this project, and this time we are going to use this 3 kilo ohms, 10 kilo ohms potentiometers, but this time we are not going to use them as variable resistors. This time, as you can see, we are using the external terminals in a serial way. This time we are going to use the full resistance. You see, we connect the first and the third lug connection, so the resistance, it's the full resistance in the potentiometer. So we got 10 kilo ohms together, and so because they are in a serial way, we got the addition of all these resistance. So we got 10 kilo ohms plus 10 kilo ohms plus 10 kilo ohms. We got 30 kilo ohms. And we need to do this because the resistance value for the photoresistance is really high. So we need a big resistance in order to get the proper reading. So let's get started. First of all, let us connect these potentiometers in the serial way. So let me change this, and then first of all I'm going to insert the legs of my potentiometer in the holes of my breadboard, like this. All you need to do is just push the element inside. It might be harder than previously used elements, but that's possible. You may need to push a little bit harder, but that's it. So first of all, let's put all these elements in the breadboard. Right now we don't have electrical connection between these elements. I just place physically these elements in my breadboard like this. No electrical connection right now. Now let's check the circuit. As you can see, the first left leg of my potentiometer should be connected to positive. So I'm going to choose this one as the left one, and so the left leg of this potentiometer is going to be connected to positive. So I get my white connector and I put this white connector in the same line of my left leg. This way I got electrical connection. I hope this is clear enough. Yes, I guess it is. So be careful, because as you can see there are some space between legs, so it's easy to commit a mistake. For example, put it in here, and as you can see there is no electrical connection between the white connector and the leg of the potentiometer. So please pay attention on this. It's really easy to commit a mistake, so check this carefully. Now the second end of my white connector goes to positive, and that's it. I got this first connection, this one. Now the right leg of the first potentiometer should be connected into the left leg of the second potentiometer, because remember we need a serial connection. It goes like this, and so it goes like this and this way. So I'm going to connect the right leg of the first potentiometer to the left leg of the second potentiometer. Let's change the video. That's it. And then I need to connect the right leg of my potentiometer, this one, with my left leg in the second potentiometer, and I need to do exactly the same from this to this. So I need another one, let's say the orange one. That's it, and that's it. So now, as you can see, we got the proper electrical connections. Now, if we check the circuit again, we can identify the right leg of the last potentiometer. It's connected to any leg on my photoresistance. Actually, this photoresistance has no polarity, so it doesn't matter if you choose any leg of the photoresistance. So this is my photoresistance. I choose any leg and I put the leg inside of the breadboard, and I put the second leg in the negative connection. This way I got negative for this one, and this one it's connected in the same line as the right leg of the last potentiometer. Let's go back to the video. Here the circuit, sorry. This is one leg connection to this photoresistance, and the second connector goes to negative. And that's it. That's all we need for the signal, right? This is going to produce an analogical signal depending on the light over the photoresistance. So I need to send this signal to an analogical input. According to my program, I want to use A0. So I need to provide the connection from this leg to A0. If I want to change that the port, the analogical port I want to use, I need to change the program. But right now I am okay with my A0 port. So this brown connector goes to the connection of the last potentiometer and the photoresistance. So the second end of my connector goes to A0. This is A0. So I put the brown one connector here, and that's it. Now, of course, we need to provide power from the breadboard, actually from the Arduino card to the breadboard. So, as always, be careful. We need to get 1, 2, 3, the fourth. It's the positive connection, and the third one is the GND. Give me a second. That's it. So there it is. Let me show you the proper connection. I know you may know this already. You may not need this, but I want to show you. There it is. The black one it's GND. The red one it's 5 volts. And so the red one goes into the red one in the breadboard. The blue one goes to the black. And now back to the circuit. Now we need to provide connection from my port number 3, Arduino card port number 3, to the signal on my servo motor, and I choose this port. This is the configuration port to send my position signal. I choose port number 3, that's why I wrote port number 3. Look, this time I'm using an analog write. This command is used to produce a PWM signal, pulse width modulation. This is the way we send the data to the servo motor. So as you can see here, we got digital PWM signal, and it has this symbol. So only ports 3, 5, 6, 9, 10 and 11 can be used as PWM signals. So if you want to change the port, you need to be sure that it is a PWM port. So it can be only 3, 5, 6, 9, 10 or 11. I want to use number 3, so again the orange connector from my Arduino card goes to the the port number 3 of my Arduino card goes to the orange connector in my circuit, in my motor. So I'm going to keep the orange color, so orange goes to orange like this, orange, orange, and then this orange second connector goes into port number 3. So this is 0, 1, 2, 3. That's it. That's port number 3 connected. Let me change the focus. Give me a second. There it is, I guess. So that's it. Port number 3. It's connected to the orange connector on my servo motor. Now all I need to do is to provide power to my motor, because as I explained previously, we got a direct current motor in here. So we need to provide power, positive to the red one, negative to the brown one. So this is really easy. I am going to use the yellow one in the middle, that is the power, the red one, like this, and then I need to provide positive connection. There it is, orange to positive, yellow to positive, yellow in the middle, and now I'm going to use purple to provide negative. So purple to the negative connection, that is the brown one, and now purple to negative in the breadboard. There it is, purple, and that's it. Now we should be ready to check this program. So just let me send the program to my Arduino. Of course, let me change the focus. Here is my program, and let me plug the Arduino card really fast, like this. And remember, every time I need to transfer my program to the card, I need to remove power connections on my circuit. So I remove this positive and negative, so all the power is in my card, and then I just transfer the program. Okay, I need to be sure that the port is properly selected Most of the times you don't need to change this, but sometimes the number changes and you need to specify the proper port. So let me change the view. Okay, only this. Send the program. You get compiling the program message, then uploading the program message, and finally done upload. And now the program is on my card. So if you start covering the photoresistance, the position starts changing. So the less light the photoresistor gets, the bigger the change on the shaft position. So you can play around trying to cover all the photoresistance or just partial covering, and then you get a different position. Well, I hope this is useful for you. I hope you enjoyed this video. Don't forget to subscribe to my channel and see you in the next video. Bye bye.